Alrighty, ladies and gentlemen, welcome to the fourth and final video for section 5 of chapter 4 in your geometry textbooks. This final video is going to cover the last little bit of information in section 5, which is the corresponding parts postulate. Now, when we use the corresponding parts postulate in a proof, when we state the reason, we are going to use the abbreviation CPCTC, and we will get to that in a minute. The corresponding parts postulate states, if two triangles are congruent, then all 6 sets of corresponding parts, that would be 3 sets of sides, and all 3 sets of angles, must be congruent as well. That's what that postulate says. So where does that abbreviation CPCTC comes from? Well, it comes from the statement, corresponding parts of congruent triangles are congruent, or CPCTC. This is the abbreviation we are going to use. Folks, this, in regular geometry, is a vocabulary word. You should know exactly, word for word, what that stands for. It is down here. This is what CPCTC stands for. Corresponding parts of congruent triangles are congruent. And we actually already talked about this back in chapter 4, section 3. We said if we have a congruent statement, such as the one on the screen right now, if triangle ABC is congruent to triangle DEF, that should immediately tell us all 6 sets of corresponding parts are congruent. And we should be able to pull those straight out of the name. Again, the first letter of each name tells us that angle A must be congruent to angle D. They both come first in the name. That means those 2 angles have to be congruent. Same for the middle. B, angle B is congruent to angle E, middle letter. Same for the third letter. Angle C must be congruent to angle F. It's the same thing for the side links, except we do 2 letters at a time. So for instance, side AB, that's the first 2 letters, is congruent to side DE, first 2 letters. Side BC is congruent to side EF, second 2 letters. And the first and last letters, AC is congruent to DF. First and last, first and last. That's what CPCTC means. If we have a congruent statement, we can use that congruent statement to state any of the 6 parts are congruent. Now, how would that come up in a proof? Thanks for asking. So here is an example of a corresponding parts postulate proof. Now, how do we tell this is a CPCTC proof? Well, pretty simply, all of the other proofs we've done in this section, what we've been asked to prove is that 2 triangles are congruent. Here, instead of being asked to prove that 2 triangles are congruent, we're being asked to prove that one of the 6 sets of parts of 2 triangles are congruent. We're being asked to prove that AD is congruent to BC. So our basic approach here is that we're going to go ahead and prove that the triangles in that picture are congruent triangles. Because if we can state that, that triangle ADB is congruent to triangle CBD, then that would be instantly enough for us to state that AD and BC are congruent, because that's one of the 6 sets of parts. So just like any other proof, it starts off with the given. Then we have a pair of alternate interior angles which are stated but not marked. ABD is the top angle that I just marked with blue, this one up here. ABD is congruent to angle CDB because they are alternate interior angles. And the alternate interior angle theorem says that if AB and CD are parallel, those 2 angles have to be congruent. We've also got a reflexive side in this picture. Both of the triangles contain side BD. So we can state that BD is congruent to itself using the reflexive property. And if we look at the picture, we have now stated enough to state that the triangles ABD and CDB are congruent because we have shown angle-side-angle congruence. Now, the second that we finish step 4, as soon as we do that, that instantly makes all the unmarked pieces of this picture congruent. We could then state any of the remaining parts were congruent. So we have enough information now to finish this proof and say that AD must be congruent to BC because AD is the first and last letters, BC are the first and last letters, which means that these have to be congruent because corresponding parts of congruent triangles are congruent. So that is how we use CPCTC in a proof. That does it for the Section 5 notes for Chapter 4. There's only one additional section that we cover in my course, covering Section 4-6. We'll be saving that information until a few days from now. Thank you very much for your time and attention.